I have returned to the collision between two rectangles, basics of thereof. Actually, I recreated another one similar to it, where I have variables for each object, my rectangle down there, and my player, of course. And then I'm doing my collision detection. And if it's detected, I change the color variable to one color. Otherwise, using an else statement, change it to something else. Great. And then, of course, down here I'm drawing the rectangle, and here using the tried and true method of declaring a couple of unnecessary variables rather than use them directly. For readability's sake, I'm copying that and drawing it down there. Okay, great. So now, so here's the real this thing here. Let's say, I want to do this collision detection with a whole bunch of rectangles, right? Instead of just this one, right? So then I have to go in and declare each of these somehow. And then I got another program. I want to do something else. So, I can copy and paste this code here, my collision detection code, and then just tweak it to whatever variables my other program's working with. Or to plan ahead and simplify things a little later down the line, I can convert all of this into a function, right? Now, the function, of course, would accept it would be a great big function call, wouldn't it? I'd have to pass the x of one, the y of one, the width, the height, its color, and the x of the other, y of its width, height, and color variables, right? So it would be like call the function, and then what do I say? 10 variables that you're passing arguments, right? So okay. Let's instead, we're going to think in terms of using object-oriented programming. Convert all of these to a couple of objects first, right? And then we can kind of demonstrate the reusability of making a one-time function that you can call on a couple of objects instead of having to worry about all these variables, right? Okay, so then I will just step forward in time using my little time machine over here. I have traveled forward in time. I have proof. Here's yesterday's paper. So basically eliminated all of the variables and have replaced them with JSON objects, also known as enumerators. I probably should have mentioned that in my JSON object tutorial, but yes, this is also referred to as an enumerator. I can take this value and it equals a number, whatever. So now this works using player.x instead of a player variable, and it's object-oriented in a sense here. Great, all the way. Okay, now, of course, so here's the nitty-gritty of our code, right? What we want to do is convert this into a reusable function. So it'll be much easier in the future to do the same thing here, or with numerous objects, right? Okay, so I'm going to copy all this and define my function var. And okay, so now I can't, let me just point something out here. I can't go two rectangles, unexpected two, huh? What? I probably maybe should mention that at lesson 1, variables, that you cannot begin a variable name with a number or any weird symbols, things like that. Variable name always has to start with a small letter, and of course, it can't be 2 words or whatever. It has to be 1 word. That's why people do the camel case thing. In case anybody wanted to know, I just kind of always took that for granted when I kind of started programming, but just to make a long story short, there you go. Okay, so Rex, I want to convert to Rex, and why don't I say what it does first? Collide. And collision is a longer word, so to try and keep this as short as possible, collide to Rex. To Rex. Doesn't have to be camel case in this case, but whatever. Equals function. Okay. Functione. And there's what it does, and that's the name of that game. Okay, so inside there, we want to paste, actually, hang on, all of that stuff. Why it's tabbed way in like that, I'm going to shift tab it back. I thought you were going to do a function call. Collide to Rex. La 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 la, and dot height. Okay, so here we have this expression going on. Yeah, it's an expression. It's all good. I'm going to return an expression. So like one way I could do that is like so. I could say if something, do something, yeah. And what the if is, of course, is the expression. I'm going to put the expression in there. Oh, okay. Mr. Onos is happy now. Yoko Onos. Here, going to now, if this, return true. Return true. Well, not tool. Return true like so. Okay. So now when I call the function, it will just automatically return true. Okay. If this is happening here, but to make it reusable, I'm not going to use player and the thingy there. I'm going to pass a couple arguments in there. So it's collision between two recs. So we'll just keep it simple and say rect1 and rect2. Okay, so now all I have to do is replace these values in here, there. Yes, I'm okay with rect1. I was using that as a variable name before, but okay, so good thing. Rect1 is the player in this case, so everything player. I could just do a quick find and replace. But there, okay, I'm done with that. Okay, rect number 2 is our thingy, whatever I'm colliding with. So rect2 here, replacing thingy. Should be good to go now. So all I have to do is pass the two object names, right? And it will automatically recognize all the things in the object by name. You see, now I don't have to pass 10 different arguments in there. Very nice, okay. Now also, this is one way to do the if statement here, where I can say if whatever this condition is, right, if all of this, then return true. And then I can do a check, and if it is that's what it is, then when I call my function, it will return this value, right? And otherwise, it will return nothing, which is the same as false. Okay, so I don't have to do the else return false in this. Nifty. Okay, but even shorter is kind of a cool way to do this. I'm going to take this whole equation here. Let me just incorporate this now, because I want these brackets. I'm going to just take this whole equation here and just exit out of there and exit out of here and exit out of there. Okay, now all this thing does is return true. Check this out. Instead of returning true, I'm going to return this equation, right? So really, it's a shortcut, very nifty kind of shortcut here. If whatever is going on in here, all of this stuff, is true, it'll return that. See, and if whatever is going on all in here is not true, then it'll return false. So slick. So now wherever I'm checking for collision here, all of this stuff before having to call something individually now. And now instead of all that, I can just use my function call by name if collide between two racks, and it automatically turns green because yes, the function does exist. Okay, if collide between two racks, pass it a couple of parameters, right? What are the parameters in this case? My thingy and my player. Let me go player first. I'm going to pass if collide two racks, player and thingy. Right? All I have to do is pass the two names in there now, and my collision function is functioning. Very slick. See? And now, from now on, whenever I want to do a collision, detection in anything, or numerous collision detections between an entire array or an array, or let's say I got a machine gun, right? And it's shooting out a bunch of bullets. That's one array, right? And I want those bullets to interact with a bunch of aliens. That's another array, right? See, so I got a bunch of an array full of this stuff checking an array full of that. For each object in the first array, I'm going to have to check all the objects in the other array, and then the next object, I'm going to check all the objects in the second, etc., till I've gone through. So makes things like that a lot simpler, to just have your reusable function. Okay. Now, whenever I want to make a new game with collision detection, and you're going to use rectangular collision oftentimes. Even say in the case where this might be an image, yeah. Who's maybe it's kind of a lot of white space around the head or whatever, but you're still going to kind of handle the collision possibly the same way for a lot of things, possibly even for a circle. Like if I'm doing a platformer or whatever, and I'm just using an ellipse for a character, I may still continue to. Let me just see if I can pencil that in here real quick. We're in my draw. Whoops, sorry. Where I'm drawing my player here. Let me just put ellipse. And now the collision is wonky because why? Because a rectangle is one way and ellipse is X and Y is in the center. Okay, but you can change that too. I believe it is what. Is it ellipse mode? I've never actually done corner. Does it like that? It doesn't. Ellipse mode. Oops. It does like that. Okay, so now I have centered my ellipse by its top left-hand corner, which you can see is illustrated by the mouse in this picture here, which is still showing the X and Y coordinates. You can make the mouse go away. I'm not going to do that in this tutorial, but remind me later. Note to self. Ellipse mode corner, right? Just to illustrate that. As I was saying, like say I got a platformer, right? And I got this ball and it's jumping, and it gets to here, right? I don't want it to go like that. No, I'll wait until it gets kind of all the way to the edge before gravity takes effect and falls. So even oftentimes when using a circular object in certain types of games, you're still going to go back to collision between rectangular collision, right? Particularly here, because I'm colliding with a block, right? And yeah, there is a much more complicated collision detection if for whatever reason you actually do need to check collision between a round object and a rectangle, which is another tutorial in itself, I guess. But there you go. That's how to make a reusable collision function, that you can just copy and paste into another program, pass it a couple object names. The only requirements are, of course, that it must have an X, a Y, a width, and a height to work. Okay?